Hello everyone, this is Chinnaiah Kalpana here. In this video, we're going to see a problem from partial differential equations. So let's get going. Problem. Eliminate the arbitrary function f from the relation z equal to f of x y by z and form partial differential equation. So we are asked to eliminate f from this equation by eliminating, f from this equation and to form a partial differential equation. Given equation or a relation says z equal to f of x y by z, considered as equation number 1. Now let's partially differentiate it with respect to x. Partially differentiating 1 with respect to x. Just apply dou by dou x on both sides of 1. Right, this gives us dou z by dou x equal to partial derivative of f of x y by z gives f dash of x y by z into inner derivative, that is dou by dou x of x y by z. Since we are partially differentiating with respect to x, so we'll treat y as constant here. And also we have the notation dou by dou x equal to p. Let's replace dou z by dou x by p. We'll get p equal to f dash of x y by z into here. Y is treated as constant, right? So we'll write this term as here y is constant, right? We can write this as y into x by z, right? So you'll get y into dou by dou x of x by z since y is constant. Now we'll write this as y into dou by dou x of x by z since y is a constant. This gives us p equal to f dash of x by z into y into partial derivative of x by y. It's z, right? X by z. We are going to use u by v whole dash formula, which is u dash v minus v dash u by v square, which gives us dou by dou x of x derivative u dash v minus v dash into u by v square z square. Clear? This gives us p equal to f dash of x y by z into y into partial derivative of x with respect to x is 1 into z minus dou z by dou x into x by z square. Right? This gives us. Now we can replace dou z by dou x by p, right? Since we have a notation p equal to dou z by dou x. Fine. Now this becomes p equal to f dash of x y by z into y into 1 into z minus px by z square. Right? Or we can write this as p equal to f dash of x y by z into yz minus pxy by z square. Consider as some equation number 2. Now let's partially differentiate 1 with respect to y. Partially differentiating 1 with respect to y. Just apply dou by dou y on both sides of 1. This gives us dou z by dou y equal to partial derivative of f of xy by z is f dash of xy by z into inner derivative, that is dou by dou y of xy by z. Okay, since we have a notation dou z by dou y equal to q, let's replace dou z by dou y by q. We'll get q equal to f dash of xy by z into, here x is treated as constant since we are partially differentiating with respect to y. So dou by dou y of xy by z can be written as dou by dou y of, here x is constant, right? We can write this fraction as x into y by z. Now x is constant, take it out, you'll get x into dou by dou y of y by z, right? So we can write this as x into dou by dou y of y by z, which gives us q equal to f dash of xy by z into x into, again apply u by v whole dash formula, u dash v dou by dou y of y into v minus dou by dou y of v into u by v square, right? This gives us q equal to f dash of xy by z into x into partial derivative of x with respect to x is 1 into z minus dou z by dou y into y by z square. Since we have a notation dou z by dou y is q, so let's replace it by q. We'll get q equal to f dash of xy by z into x into 1 into z minus qy by z square, right? Which gives us q equal to f dash of xy by z into x into, yeah, just multiply the numerator with this x, you'll get xz minus qxy by z square. Consider as equation number 3. Now observe 2 and 3. In both the equations we have z of f dash of xy by z, just eliminated using 2 by 3. We have equation 2 and equation 3, right? Using 2 by 3 we'll eliminate f dash of x by y. LHS of 2 by LHS of 3, RHS of 2 by RHS of 3, where f dash of xy by z gets cancelled. You can cancel z here itself, or you can write it as p by q equal to yz minus pxy by z square into z square by xz minus qxy, where z square gets cancelled, and you'll get p by q equal to yz minus pxy by xz minus qxy. Just simplify it by making a cross multiplication. P times xz minus qxy equal to q times yz minus pxy, which gives us pxz minus pqxy equal to qyz minus pqxy, where minus pqxy gets cancelled, and we'll get pxz equal to qyz. You can just cancel z here itself, or take this z to RHS. Okay, take this z to RHS and cancel it happily. You'll get Px equal to Qy, which is the required partial differential equation to our problem. Therefore, Px equal to Qy is the required partial differential equation. Which completes the problem. Fine. Well, we have seen a problem from partial differential equation in this video. I hope you'll understand. We'll see you in the next video. Until then, bye bye.